Welcome to Study Loop.
41.32 is about the compound gallium arsenide, which is a semiconductor used for LEDs and solar panels and things. Silicon is also used for solar panels, but sometimes they use gallium arsenide. So the first thing we want to do is talk about its crystal structure and to draw out a version of it. However, it's kind of sort of a somewhat complicated 3D thing. So to actually show you what it looks like, I have this image from Wikipedia that has been released to the public domain by its author. And so you can see you can say that these sort of gray ones are galliums, and the yellow ones are arsenics. And so we can try and draw this from like a top-down view, say. We use red for arsenic. And then slightly smaller green dots for the galliums to sort of represent that they're further away. And then down even further than that would be more galliums. That would be these. And then in between them, we'd have some arsenics over here that are further away than these, but not as far as those. And then the bonds between them, so drawing them curved just so you don't get the galliums or the arsenics connected together. So we have that, and then each of those is connected to those down there, and this is connected to that. Let's see. This is connected to that and that. Yeah. So you have each gallium is connected to 4 arsenics, or each arsenic is connected to 4 galliums. And it's, this sort of weird thing. This is called a cubic diamond lattice. Except the diamonds have only carbon atoms here. And so sometimes to distinguish between crystals with just one type of atom and, in this case, 2, this is also named after a common mineral that has the same crystal structure but with 2 things, which is sphalerite, which is an ore of zinc that contains zincs and sulfurs. So yeah, so this is sort of complicated, but here's just to give you a good idea of what the actual structure looks like, rather than trying to draw something like this and just say use your imagination. This is what we're actually trying to draw. So now moving on to the actual parts of the problem. We want to know what the net charge of the gallium ion core is. So for both of them, the 3p, 3d, and 4s shells are filled. And then the 4p shell is partially filled. And so we have a neutral arsenic atom. It has 3 electrons in the 4p shell, and a gallium atom has 1 electron. So we need 8 shared electrons for the 4 bonds that each one has. They have to share both electrons from the 4p and the 4s shells. So the gallium core ends up having a charge of positive 3 elementary charges, because it loses its 1 4p electron and then 2 of its 4s electrons. And then the arsenic core has a charge of plus 5 elementary charges, because it loses all 3 of its 4p electrons and 2 of its 4s electrons. And so you can see that these, since there's an equal number of gallium and arsenic atoms, these average out to a charge of wait a minute, plus plus 3e. So this averages out to having a charge of plus 4e on each core, which is what happens with silicon, but since it has 4 valence electrons, it doesn't need to be partnered with anything else to be a semiconductor. So part C, the last one here, is how many electrons per bond are there? And so, as we mentioned in part A, the same thing that happens for silicon has to happen, is that they have 8 electrons they're sharing, and there are 4 bonds. So there are 2 electrons per bond.